Okay, so hello everybody. We're
Hi.
very, very pleased to have some fantastic guests with us today for this hopefully very interesting session on cutting edge satellites. We've got with us Nir-Nissim from IAI, Avi Shabtai, CEO of Ramon Space, Kelly Larson all the way from the US. In fact, Avi's from the US as well right now, but Kelly Larson all the way from the US, CEO of Aquarian Space, Arie Greisman-Ran from Elbit, and Arie Halsband from previously Effective Space, nowadays Astroscale Israel. And we're going to start by doing a few minutes round where everyone is going to tell us what exciting things they are doing now with their cutting edge satellites. And then we're going to have a bit of a discussion about the technology, the ecosystem, and quite a few other things. And please feel free to write your questions and we'll try to get to them towards the end. So let's be polite. Ladies first. Kelly, go for it. Tell us a bit about what you're doing there at Aquarian Space.
Great. Well, beautiful to be here. Thank you so much. Yeah, so at Aquarian Space, we're talking about breakthrough technologies here, and the breakthrough technology that we're really bringing is about bringing our technology to the moon. So we all know that space is hot right now. We know that space right now is actually entering a new era, and that is the era of going back to the moon, and this time to stay. And that can sound like science fiction, but it's not. There are dozens of public and private finance programs right now, from the US to Israel to Japan, across the world, that are funding people and robots to go back to the moon and stay this time. And that multi-billion-dollar lunar economy that is happening is not going to happen without good, reliable communications. Every one of those spacecraft needs to be able to communicate between the Earth and the moon. So in the last 60 years, there's been little change in deep space communications, and it's currently fairly oversubscribed. So deep space and lunar communications are currently provided by the Deep Space Network. And anyone who works in any space agencies or is going to the moon lately can tell you that it's hard to get access to these things. So what Aquarian is doing is we are essentially solving that problem with relay satellites. So we're starting at the moon, and then we're stringing relay satellites through the solar system. So if you can imagine how cell phone towers surround the Earth to direct signals, we are doing that with relay satellites by the moon, and then by Mars, and then throughout the solar system. So what we are in the lead to do is to be the leading internet service provider for the solar system. And we are delighted to do that. And we think that, and we know that that infrastructure is necessary to do the breakthrough, which is very soon a massive lunar economy and a new era of space for all of us to be able to actually be on the moon, to stay on the moon, to explore the moon, and then go to Mars and really be in the solar system in a new way, which we know is happening within the next decade.
Kelly, thank you very much. That sounds sort of science fiction and very, very interesting. And I wish you were around a couple of years ago when we were doing Bereshit, and we really would have liked a bit of that communication. So I really envy the next guys around that are going to do that, hopefully with your help. So let's continue going around. Arie, to you.
Good afternoon, I'm Arie Halsband. I'm a Managing Director of Astroscale Israel. I'm part of the Astroscale group. I'm involved in the space industry since 1996. Started as a team leader at IAI, and retired from IAI in 2011 as a space division manager. I established Effective Space in 2013 and moved to Astroscale in 2020 after asset purchase agreement successfully closed. So Astroscale is the first company which is totally devoted to space sustainability. And our vision is to develop technologies which will keep space sustainable for future generations. So what we are developing is active debris removal, end of life of satellites, life extension for geo communication satellites, and situational awareness for satellites in space. Astroscale Israel is a subsidiary of Astroscale US and is developing the technologies for the life extension payload. So actually we are the payload manufacturer, the payload developer, and we develop all the technologies needed in order to do rendezvous and docking in space. So, so these technologies include navigation, feedback from sensors to work during the line of sight navigation, orbital maneuvers, and the docking mechanism. We also develop several service missions, how to operate the tandem service and client after docking to keep them in the required orbital slot, including the orbital slot, right orbital slot and attitude correction tolerances. Other Astroscale groups are developing other lines of business. For example, end of life is developed in the UK. And this is aimed to remove failed satellites in constellations, considering that around 46,000 satellites will be launched by 2030, and a considerable amount will fail due to the probability of failure. So we'll have enough customers to bring into the atmosphere to be burned. In March 2021, Astroscale launched a self-funded mission to demonstrate the debris removal called ELSA-D. Since launch, this spacecraft actually performed a series of tests which paved the way for additional tests and to demonstrate the debris removal techniques. The removal mission will focus on removing unprepared satellites. In October 2019, JAXA issued an RFP for the commercial removal of debris removal demonstration mission, which was awarded to Astroscale. The mission will be implemented in two phases, a demonstration of approaching first, and then removal for Japanese-made upper stage rocket. So this is in short. I could speak about a year on that.
Thank you very much, Arie. That sounds very, very complicated and like a challenging business case, but I personally am convinced that's there, and I really, really, really am waiting to see success of Astroscale in general, and specifically, I would love to see a life extension mission with such exciting technology. Uri, tell us a bit about what you are doing at Elbit.
Hello. So yes, thank you very much. So in Elbit, we are trying to develop new space solutions. And actually, when we're trying to ask ourselves, what can we offer to the world that is not there yet, leveraging the existing technologies and heritage of Elbit, we came to a conclusion that one of the things that we can do there is to develop a fast scanning mirror, which is actually a lightweight optical surface that is bound to a very accurate and fast control mechanism. When we will have this fast scanning mechanism, and we will be able to control it and to manipulate and rotate this mirror 360 degrees and up and down, it will enable us to guide the line of sight of the satellite in a very, very flexible manner, and to avoid the push broom concept disadvantage of imaging large and unneeded areas. We think that with this technology, we'll be able to offer very, very ultra high revisit time. And as this mirror can scan dozens of images per second in a mosaic pattern, we can improve the ratio of the eye instantaneous field of view to the optical aperture, providing exceptional spatial resolution for a very small satellites. Now, with this core of the gimbal fast scanning mirror, we selected first to go with the high resolution and very sensitive thermal IR sensor. We know that there is a scarce of thermal imaging from space, and we decided to develop two demonstrators that will use this band to enable us to see and observe things and objects 24 hours a day. And we will try to demonstrate both identification of space debris monitoring as well as thermal visualization of the ground. We are working here with the semiconductor device, SED, who are helping us to implement a cutting-edge 10-micron sensor that they are adapting for us. On top of that, and in order to control this new concept, we're implementing a real-time mission management software, which is Elbit core, and we are very much experienced with the development of these mission computers to aircraft and to helicopters. So we're adopting it to satellites. And this will help us to optimize the imaging schedule. So by managing the operation time and standby sequence of the sensors and the mission itself, we can overcome some power and bandwidth limitations that are quite scarce in small satellites form fit. After that, we're going to have the ability to implement onboard algorithms with a powerful GPU. And that will enable us to extract the metadata of what we see and only to send the required information and not the bulk range of data. Following the maturity of this technology demonstrator, we will try to implement an inter-satellite link in and between planes, which will help us to schedule tasks between virtual subgroups of our constellation. And this will help us to schedule imaging missions to the optimized satellites and to point the fast scanning mirror to the desired area of interest. This will help us to get immediate tasking requests and to provide on-demand coverage. In some cases and in some latitudes, our response times will be down to minutes or less. That's it.
Thanks, Arie. Sounds definitely a breakthrough. I think high resolution, high revisit rate IR doesn't exist. And if you manage to make that work, it'll be very exciting. And you mentioned onboard processing. So I think that's a great cue for Avi to tell us a bit about what they're doing at Ramon Space.
Okay, thanks, Opher. Hello, everyone. My name is Avi Shabtai. I'm the CEO of Ramon Space. And at Ramon Space, we're pretty much dealing with data in space. We're building computing infrastructure for space with a goal to lead the way towards smart and autonomous satellites. As you probably know, data in space increase continuously, especially in the last few years, and it's going to grow exponentially in the following years. And what you can do with data generally is you can either store it, you can process it, or you can move it. And when combining these three, you can build the infrastructure for space to enable new services, deploying software in space, and really to bring what we're calling at Ramon Space, bringing Earth-like computing to space. We're building a lot of technology in-house around computing infrastructure, and a lot of it is also centralized around building our own silicon, which is rad-hard DSP machine learning processors that are being used with our systems. We've been in space since 2014 by now, and we're celebrating very exciting period, I guess, this year, seeing so many missions that we've been part of very successfully. I can say pretty much all over the solar system and in many orbiting satellites. As of today, we're growing rapidly, which is, I think, very good for both the industry and also the Israeli industry with regards to space. We have offices now in Israel and the US, and looking forward for the future of space.
Very exciting, Avi. I think you're probably going to change a bit about the way space looks. So we'll be talking about that when I think about the follow-up on questions. And Meir, it's over to you to wrap it up.
Okay, thank you. My name is Nir-Nissim. I'm Director of Advanced Space Systems, which is pretty much a small startup within the IAI, the big defense corporate. We do light satellites and we do deep space missions, which is not a huge challenge. We have amazing heritage, great storage rooms to ransack for advanced avionics, and very experienced disciplines. The big challenge is the mind shift and not getting cut by the edges. Cutting edge means you've got to select the edges right. And I believe that new space, the new space business made a clear choice towards enhanced service models. Whether it's on all spectral ranges, visible, thermal, RF, whether passive or active, we see the lead providers opting for mid-range systems, very effective ones, capable of near high performance, and in some places like the large bandwidth connectivity, even surpassing the heritage systems. We see the matrices by which we define and build the business change to watts transformed to bandwidth X users or to pixels or square kilometers per dollar over time. And this meets II at a very interesting point because we are in a position to scale down from our heritage systems and provide a very, very cost-efficient solution to those mid-weight, high-end platforms. We build upon powerful long-range payloads. In our analysis, a constellation of 50-centimeter aperture surveillance satellites beats 35-centimeter aperture by performance with half the number of satellites and the lower total cost of ownership. Scaling down from our Texel satellite to a small SAR platform allows pretty decent range for high revisit and amazing SNR. We also use, as I mentioned, our leading avionics, which are still, after 3 decades, world leaders in weight effectiveness. Having to launch the wrong way with indigenous, but let's say modest launching capability forced us to minimize from age to age, and our normal platform relative to a high-end satellite is 30% in weight. This allowed for Bereshit to be the first lightweight lunar lander by far. We see the competition catching up with Bereshit 4 or 5 years later. Another thing which is important that we bring to the game is we know how to build mission-oriented. We have mechanical agility for very affordable prices for collecting the important images in every pass. We use in communication satellites wideband channelizer to squeeze in and make better use of the bandwidth that we put out there. And we have elaborate tasking capabilities, and even the download, we can download the bulk data that our satellites generate, which means at the bottom line, we squeeze more from every second in space and hence from every invested dollar, which brings us to the real edge. Taking a defense corporate to the venture capital market streamlining production line in a place that is used to do one-offs, and leveraging venture capital funding is really cutting the edge. Opher.
Thanks a lot, Meir. And if we get a view of the whole crew now as we're going into the discussion, first I want to say that we're all talking about having small satellites around. The only one that's actually doing it in this panel is Kelly. So welcome to the small satellite that we've got joining you there, Kelly. And so let's talk a bit about constellations and smaller low-cost satellites that have been flourishing as part of this new space revolution. And all of our panel members are either building small satellites or working on programs that will be utilizing small satellites, and all of them are working on multi-satellite programs. And so it brings to mind a few questions about this issue. First of all, the big, expensive, large satellites, what's their future? Are they going to be around? Are they going to be replaced by these small satellite constellations? Are they going to be complementing them? Are we going to still see billion-dollar satellites flying up there in the same amounts as we've been seeing up to now? Or are the guys making them, should they start being worried about that? What type of new technologies and capabilities and services do you think we might see, not next year, everyone knows that, in 10 years' time, in 15 years' time? What are the people sitting in a panel in 2030 here going to be talking about in small satellites and constellations? Are they cost effective? And is this trend here to stay? So let's sort of go around the room and pick whatever one of those sub questions you want to talk about, and let's go in the same order we had before. So Kelly, it's up to you again.
Hello, me and my helper here. This is the beauty of having the virtual conference. Get extra
It is.
So I would say absolutely. You know, when we're talking about deep space, yes, he agrees. When we're talking about deep space, we are talking about. Oh, here, hold on. There we go. When we're talking about deep space, having the level of power that some of these big satellites provides is still not quite replaceable, I think, when we come to what's going to be interesting as we go in the future. Now, there's a lot happening in the small sat world, and there's a lot that we can do with that. But when it comes to being at Mars, when it comes to being at other farther away places in the solar system, we don't need them right now necessarily, but I think there's a place for it. Yeah, so I think I wouldn't write them off yet, and I am continually amazed by the new technology coming out and what it makes possible.
Absolutely. Arie.
Yes, so sometimes there are fundamental changes in technology which we cannot ignore. Processing power, sensor sensitivities, size and mass of electronic units, etc., or some breakthrough in the physics world, and all of these make it possible to have more with less. And in time, it can enable us to have smaller devices with better performances and functionality. And we saw this with the PCs and smartphones and cameras and various other high-tech products. So yes, sometimes smaller is better because it can do more with less. But there are some other groups of products which in time approaches maturity. Cars are not getting smaller, and commercial aircraft hardly goes faster. So with time, we just approach the limits. The curve is being flattened, and of course, until we'll have a new and elementary breakthrough, this is going to be stabilized. So I think with satellites, you're at the early stage of maturity, and I think that there is a lot of room for improvement and to enable a new and smaller satellite to do more. And yes, so I think that in time we will see more and more capable small satellites. And if we take it to the extreme, so in the past we had thousands of kilograms or hundreds of kilograms. We're going down to dozens of kilograms, and CubeSat is maybe 3 or 4 or 10 kilograms. If we try to think about this to the far edge on the right side, we'll have 10 grams or several gram satellites and widely storms very huge swarms, of miniature satellites, and the main question is, what is it good for? Normally, we cannot express or we cannot predict really the future. I cannot so far. So largely, I believe that we'll have a mix. We'll have a constellation of small satellites which will work together. They will empower each other. They will cover for failures, and they will make a mission together. But I also think that the larger satellites will be there, and they will be also capable to do more and more functionality, and they will have more and more features. And last comment here, when we think about a larger amount of small satellites that are working together in constellations, one of the backbone technologies that is yet to be matured is the ISL, the Inter-Satellite Link Communication Channel. We know that the optic channels are they have progress, but it's still a big challenge. And until this will be solved, the ability to distribute missions between satellites is going to be quite difficult.
So Arie, are these constellations going to provide more room for debris mitigation and for clearing away the garbage, or are they going to take away the business case for life extension?
Well, first of all, I would like to answer the basic questions that you asked about large satellites and small satellites. So, as your predecessor, I was dealing with that at IAI when everybody said that nano satellites will replace the microsatellites and small satellites. So this is not the case. I think that it depends on the mission. And big satellites will still have a room where they have an advantage. For example, large communication satellites, if there are a lot of missions and large area to cover, so when you divide the amount of the fund to cover the overhead of the avionics and the structure is cheaper. Now, so I think that for communication, for example, we can see small satellites like Astroscale, geosatellites working together, complementing large satellites, and make it more efficient, both from performance and agility. If we take another advantage, scientific satellites. So we just the Webb satellites, James Webb satellite was launched. This is a huge satellite. No small satellite can replace this mission. So that is you can see a mission that essentially needs a very large satellite. Now, if we take reconnaissance from space, so I think that here we can work with constellations of large satellites, small amount of large satellites that can see very small details, and in addition, small satellites which actually complement them and have a very small revisit time to look after variations. But the same targets that were detected by the large satellites, now you can revisit them more frequently by small satellites and see where they're moving. So this is, I think that I can't see how small satellite will completely replace large satellites. So this is for the first question.
Thanks very much, Arie. And Avi, let's go for a short answer on your side. And I think your main business is constellations, isn't it?
Just a short one is I do think that they will coexist together. And I think that the large-scale satellites will start transforming to be more what I call multi-service satellites. They will start giving services not only to Earth, but to other satellites in orbit. And we will see different type of large-scale satellites in orbit with new types of services. And especially as it's become more and more data-centric type of approach.
So Avi, as a guy that's providing the computing power to some of these satellites, or to a lot of them, are you going to see a lot more computing power on the big satellites than on the small ones?
I think we're going to see more and more computing in both cases. It depends on what's the computing goal is going to be focused on, and the scale of the computing that is required. But if we talk about the transition towards data, it's going to be, I think that computing will be in all satellites. And as you know, the more you start using computing, you need more and more and more, same like storage. And we will see them in both, just for a different type of application.
Meir,
Yes.
the guys in 10 years, are they going to be making small satellites, large ones, or both?
Let me remind you the job definition that you gave me. You should build satellites up to your weight. And as a disciplined employee, I only multiplied by 2. This was the most mission-effective satellite for imaging, both the small cell satellite and the small electro-optic satellite. And now I must tell you, former boss, that I'm multiplying by pi. If you want to go global and spread this juice around the world, we should enhance the power system, and it's very, very cost efficient. While before we were volume limited in the launch, now we fill up the weight capacity as well. And I believe that the working horses in 10 years will be the mid-range, several hundred of kilogram satellites. What is going smaller, already successfully in place, is the price. They're already being deployed up there in the small millions range, and that will keep the business running. And I completely agree with the previous speakers. There will have to be a net in which you will connect with high-range satellites and streamline the service between them. So I think the image that we will see in 10 years is everything growing larger. Imaging capacity, bandwidth, number of satellites, and the challenge will be to manage them and keep their tracks free and do a proper obstacle avoidance and maneuvering systems, because right now it's going like the frigate commander ordering a lighthouse to clear its path.
Smaller satellites are going to grow bigger, but cheaper. Interesting. And you know what? I think I agree with you on that one. Now, the new space revolution, a large part of that has been about space as a service. And when we say that, we're used to how space gives service to us down here on Earth. But 2 of you, Arie and Kelly, are actually working on providing service to other spacecraft, which is a big step forward. That's a sort of a dramatic conceptual change in the ecosystem. So is this going to grow? Are we going to see more types of services being provided to spacecraft? What type of services? And for the other guys, what would you like to see service providers providing your satellites as we create this ecosystem? Kelly, go ahead.
Wow, there's a lot. There's a lot I could say on this topic. Absolutely. This is, I think, a huge market, especially as we're getting farther away from the planet. The farther we get toward the moon, we get toward Mars. This idea of putting spacecraft up there to just die is kind of the old model. That's not going to continue. It's not sustainable in any way. It's not economically sustainable. When they just fly around in space, they become weapons, because, just space junk becomes a serious danger for people, right? So, but on top of that, it's just expensive and it's a bad use of energy, right? So what we know is that I think spacecraft are going to continue to become more long-term, and they're going to become more serviceable, from refueling to adding or changing capacities to fixing things to recycling things. I mean, I know people that have businesses that are pulling together space junk to then process the metal and recycle it. and then build new parts out of it with 3D printing. I mean, the space as a service economy, I think, or the service economy in the space ecosystem, I think is huge. I think it's going to start at the moon, like so much of the outer beyond Earth space economy is. And I think it's going to grow fast. And I think it's pretty exciting. It's kind of like, you know, I mean, when they call space the next frontier, right? We're seeing that start to happen around the moon right now with these kinds of businesses. And, you know, I mean, we're bringing communications. That's fantastic and absolutely necessary. And I'm inspired by some of the other services that are coming in and watching this ecosystem grow.
Absolutely mind-blowing. Arie, a 30-second answer.
Tough, but so I think that service in space is enabler for $1 trillion industry. It will grow, and as there is a service, additional services just emerged. So we just signed a service for a service, which is a fueling for a servicer, which is amazing. This is a game changer. So now we can refuel our servicer and do more work, more service, with the same service, and to decouple it for the launch weight, which is a big constraint. So I think that service in space is an enabler for everything that we see in the ecosystem. For example, if we see manufacturing in space, pharma in space, they all need a huge amount of service. If we see that space hazard will be intensified, so satellites will be damaged, they will need to be fixed, and this is a service that can fix satellites in space. So I think that there is a huge future for service in space.
Perfect. Thank you very much. I'm going to skip to the next question. The new space economy in the US has been growing dramatically. It doesn't matter if you measure it by investment, by the number of new companies, by the number of launches, by the number of satellites up there. It's crazy. In Europe, they got off to a late start, but they're moving forward and accelerating. The Israeli ecosystem, not moving forward very fast, unfortunately. And we couldn't even find a young new face for our panel today. Someone asked us in the questions here, commented on that. We couldn't find them. Believe me, we looked. A couple of them were talking to the other panel, but even they're not new. They're 4 or 5 years old. So why is that? Why is it moving slowly here? Why is it moving so fast in the US? What is the government's role in this? Are they helping? Are they hindering? Do they need to fund? Do they need to provide the business or the developing technology? Do they need to assume the risk? Why do we need them involved? Is it their business? Go for it. Let's start with the guys who didn't talk before. Avi, go ahead.
I think it's a combination. Of course, the government play in space is important and can drive some of the industry forward. However, I think that a lot of it has to do at the end of the day with private money going into and fueling the industry, like happening, you know, with other industries. I do believe, looking at other markets, such as the automotive market, for example, if you would ask the same question about the automotive market probably 10 years ago, you would get the same answer. But once you start to see new business models, and once you start to see private money going in from venture capital, then I think you will see the huge transition of the space industry and the space new ventures in Israel. I think we're starting to see this path growing now. And I think you will see more and more space companies coming out of the Israeli industry. The space fits very well, I believe, with the Israeli R&D DNA of deep type of technologies, really diving into the bits and bytes of things and a lot of innovation. So I truly think that if a company and entrepreneurs, they have good business models and they can build around it, a company, they can certainly raise the money through the private channels. There is and this transition will happen. I think we're at the beginning of this transition.
Meir, what do you think? Short answer.
I think it's a dichotomy. If you look on the cyber market, the government, one government officer made a huge difference. we cannot do with government officials startup environment. I think very small funds, just doubling the agency's budget with mentors to small startups that will push them to market, like Avi said, teach them what the IT and cyber guys already learned, might do a lot.
Very good.
Yeah, I think that I have some experience with that. So speaking from my experience, so if we want to grow a big economy, space economy in Israel, we need big companies. So the space government market is actually closed for non-local players. There is by US Act in the US, ESA programs are closed for non-ESA participants in Tier 1. You can still be a supplier for components, but not Tier 1. So Israel stayed alone, and this is quite difficult. So I think that in order to encourage the companies to grow, we need some assistance from the government. Now, the private money is hesitant to take the risk. And it's also already joining when the risk is removed. So the task of the government is to have the private money, the VCs, which now are looking at the space. So two companies now which are backed by private money. One of them is Avis. So in order for them to remove the risk, we should have some government guarantees, for example, which we don't have in Israel. Another way is that we must join a large market in order to participate in governmental market, because this is the big market. In the US, the bigger market is the governmental market. If you take Bereshit, for example, 3 other companies in the US receive more money than the Bereshit cost from NASA. So if we could, for example, participate in Bereshit at NASA, we could actually do with Bereshit 2 on NASA money. So I think that the answer is that, one, we need government guarantees and government participant to remove some of the risk, to allow private money to enter, and second, to have a bigger market by joining some alliances.
Thanks, Arie. And I'll use that to push it over to Kelly for the last 20 seconds. How important is the government to your business? And to push you to the wall on that, if NASA budget got cut to $3 billion a year, okay, way down, would you have your business around, or are you dependent on what they're giving at the end of the line?
We absolutely would have our business around. We're building our business beyond NASA. And what NASA's done to open up to small businesses has been huge. And I want to say the most important thing that NASA's doing right now is the CLIPS program, which is essentially funding commercial programs, commercial companies to come and do their missions for them on the moon, which is then allowing those commercial companies to grow and grow beyond NASA. And I think it's a really smart way that they're approaching this to grow the economy.
I absolutely agree, and CLIPS is fascinating. Thank you very much to all our panel members. I wish we had another hour to do this, but I've got this red thing in front of my eyes here saying we've done too long. Thank you very much for the audience as well. It's been a pleasure being with you all.
Thank you so much.
Thank you. Toda, shalom.
Shalom.